Hi class, in this lecture here we're going to start talking about solving exponential and logarithmic equations. Now what I'm going to introduce in this lecture is I'm going to talk about 4 different ways here to solve either exponential or logarithmic equations, and I'm going to work through a ton of examples of each. So this lecture is going to be basically introduce a concept, then show an example, and then show another and another and another. And so I'm going to try to cover a lot of different examples, but you might run into problems, if you try on your own, that aren't exactly like the ones I covered in class, but the process or procedure will still be the same. Okay, so even though it might look a little different, you're still going to have all the methods you need to solve here. Okay, so here's what we're going to walk through. Okay, we're going to talk about use what's called like bases to solve exponential equations. Then we're going to use logarithms to solve exponential equations. And then what we're going to do is we're going to use the definition of logarithms to solve logarithmic equations. And then finally, the last thing we're going to do is we're going to use the one-to-one property of logarithms to solve logarithm equations. Okay, so let's start with this. Okay, and this is solving exponential equations by expressing each side as a power of the same base. So here's the deal. If b to the m is equal to b to the n, so notice here the bases are the same. So like for example, something like this. Okay. 2 to the x power is equal 2 to the 3, okay? Well, then it just has to be then that the exponents, m and n, are equal, okay? That's what we're saying here. So you can see here that this has to be x is equal to 3, all right? So if the bases are the same, then the exponents have to be the same. So what we're going to do is when we solve these problems, what we're going to do is we're going to rewrite equations of the form so the bases are the same. That's important. Bases are the same. Then what we'll do is you're going to have the exponents or the exponential, the expression that's in the exponents set equal to each other, and then you're going to solve for the variable. Okay, so let's just work through a ton of examples here so you can see this in action. All right, so let's solve each of these. So here'll be the first one. Let's look at 5 raised to the 2x minus 1 is equal to 125. All right, well, you notice right off the bat that the bases aren't the same, but 125, that's 5 cubed. So look, we would have 5 to the 2x minus 1 is equal to 5 cubed. Well, look, bases are the same. Bases are the same. So then it must be, then we must have, so then thus, 2x minus 1 has to be equal to 3. And then look, this is just such a simple, equation to solve, right? Add 1 to each side, divide by 2, and your solution here is that x is equal to 2. And look, if you were to check this, right? If you were to plug 2 back into this, 2 times 2 is 4, minus 1 is 3, 5 cubed is 125. So it works out. So the trick here, the key was just to start off rewriting it, okay, so that the bases are the same. All right, let's try this one. 3 to the 1 minus x power is equal to 1 over 27. Well, look, you got to rewrite this somehow. Okay, so first off, I'm going to recognize that this is 27 to the negative 1 power. Well, then look, what is 27? 27 is 3 cubed. So this ends up being 3 to the 1 minus x is equal to 3 to the negative 3rd power. And it's like, oh, great, we got it. Okay, the bases are the same. Bases are the same. So thus, the exponents, 1 minus x has to be equal to minus 3. All right, so start off by what first? Subtracting 1 from each side. You get minus x is equal to minus 4. Divide by negative 1. And x is equal to 4. Which totally works out, right? Because if you plug 4 in here, you get 1 minus 4 is minus 3, and 3 to the negative 3rd power is indeed 1 over 27. All right, let's try this one. Let's look at 4 to the x is equal to 1 over the square root of 2. All right, so again, you're going to bring this up, okay, as 2 to the negative 1/2 power. Like that. And then it's like, well, the bases aren't the same, but you got to ask yourself, what is 4? 4 is 2 squared. Power to a power you multiply. So this is 2 raised to the 2x is equal to 2 to the minus 1/2. So like the hard part here is figuring out how to rewrite this. And then like as soon as you figure out how to rewrite it, it's like, okay, all right. Well then thus the exponents have to be the same. So 2x has to be equal to minus 1/2. When you divide each side by 2, you get x is equal to minus 1/4. And we got it. Okay. I don't know. Let's try another one. All right. Let's try maybe two little bit harder ones, or not. Let's just keep practicing here. Let's try this one. E to the x plus 4 is equal to 1 over e to the 2x. And then also let's try this one here. Let's look at 8 to the 1 minus x power is equal to the 4 raised to the x plus 2 power. And what you should do is consider, like, I'm going to be quiet for a couple seconds. I encourage you to pause the video, pause the lecture as you're doing this. Try to work these problems out, right? And then, and then come back and, unpause the video and see if you get the same solution I do. All right, so hopefully you did that. Let me show you now how I would do this. So you have to rewrite this, right? So I'm going to bring this up as a negative exponent. So this is e to the x plus 4 is equal to e to the minus 2x. So look, the bases are the same. The base here is e. So thus we have x plus 4 is equal to minus 2x. Just subtract the x over. Divide both sides by minus 3. And you're just left with x is equal to negative 4/3. And that's it. So here, this one's tricky because you have 8 and 4. Well, 8 is the same thing as 2 cubed. That was the way you had to write it. And 4 is the same thing as 2 squared. Well, when you have a power to a power, you multiply, right? Okay, so this is 2 raised to the 3 times 1 minus x power is equal to 2 raised to the 2 times x plus 2 power. So thus, this is what you have. You have 3 times 1 minus x, because the bases are the same, is equal to 2 times x plus 2. So just solve this linear equation. Like these all boil down to just, this is a very simple linear equation to solve. So this is 3 minus 3x is equal to 2x plus 4. Right? So how are you going to do this? I'm going to add 3x to each side. So these are gone. So I get 3 is equal to 5x plus 4. Subtract 4 to each side. So I get minus 1 is equal to 5x. Divide by 5. And your last step here, you see that x is equal to minus 1/5. So that was the first thing you're going to do here when you have these exponential problems is like look to see if you can get a common base. If you can get a common base, then you're just going to set the exponents equal to each other. Okay, not too bad. All right, but now let's talk about problems where you can't necessarily do that. All right, so in this case, what you're going to do is you're going to need to use logarithms to solve exponential equations. Okay, and it goes like this. So all you're going to do is you're going to isolate the exponential expression. So if you have one side, has, both sides have the exponential expression, see if you can somehow, just get one side of the equation to just be the exponential expression. Okay. Then what you're going to do is you're going to take the common log of both sides of the equation for base 10. Or you can take the natural log of both sides on the equation for other sides, for equations for other bases than 10. Okay? So just take the log or the natural log of each side of the equation. And this will make sense once you see the first problem. So then you're just going to simplify using the following properties. Okay, you'll see it. All right, natural log of b to the x is equal to x, natural log of b, or natural log of e to the x is equal to x, or log of 10 to the x is equal to x. And then you're going to solve for the variable. Okay. These, you're going to notice, it's just going to take a little bit of practice. And then I promise you, once you see me do a couple, it doesn't get too bad. All right, so here'll be the first one. So we want to solve this exponential equation. 10 to the x is equal to 3.91. All right, well, notice that you can't write these as common bases, okay? So when you have 10 here, you're going to take the log of both sides. So log of 10x, 10 to the x, is equal to log of 3.91. Well, look, using our rules of logs, look. Log of 10 to the x, that's just equal to x. So you're just left with x here. So all I'm saying here is x is equal to log of 3.91. And you can leave it like that. That's the exact solution. Or you can grab your calculator here. And you can say, okay, well, what is log of 3.91? And it's 0.59. I'll go out 3 decimal places, so 0.592. All right, let's try this one. Let's look at 9 e to the x is equal to 107. All right, so the first thing you're going to want to do is you're going to want to isolate the e to the x. So the first thing you're going to do is you're going to divide by 9, okay? So you have e to the x is equal to 107 divided by 9. Now what you're going to do here, look, if you take the natural log of e to the x, you're just going to get x by itself. That's what you want. You want to solve for x. So you're going to take the natural log of each side. Because whatever you do to one side of the equation, you have to do to the other. And look, this is what you're left with. You're just left with x is equal to the natural log of 107 divided by 9. And then you can use your calculator here to get a rough estimate of the value. So natural log, and it was 107 divided by 9. Close the parentheses. And look, this is roughly 2.476 when I round it. 2.476. All right, let's try this one. Let's look at 7 raised to the x plus 2 is equal to 410. Okay, now here it doesn't matter, like if you use log or natural log here, but I'm always going to default to the natural log here. So look, I want to bring the exponent down. So I'm going to take the natural log of each side. So this is the natural log of 7x plus 2 is equal to the natural log of 410. Well, look, what my rules of log say is I can bring the exponent down in front now. So this is x plus 2 times the natural log of 7 is equal to the natural log of 410. All right, so now it's like, well, geez, how do I solve this? I want to get x by itself. Well, look, natural log of 7 is just a constant. So let me divide both sides by the natural log of 7. These cancel. You're left with x plus 2 is equal to the natural log of 410, divided by the natural log of 7. And then how do you get the x by itself? You're just going to subtract 2 over. And so that is the exact solution. X is equal to the natural log of 410 divided by the natural log of 7 minus 2. But let's plug it into our calculator and get an approximate solution. Okay. So we have the natural log of 410 divided by the natural log of 7. And then I'm going to subtract 2. And it's roughly 1.092 when I round it to 3 decimal places. 1.092. So these can get a little messy, little messy as you can see here. Okay. All right, let's do a crazy one here. Okay, one that's going to involve a lot of steps. Okay, and you're going to notice as you do this, you are going to have to be meticulous. Okay. All right, so let's try this one. Let's look at 5 raised to the 2x plus 3 power is equal to, okay, 3 raised to the x minus 1 power. All right, this is crazy. All right, so be careful here. All right, so you want to bring down the exponents here. All right, so what you're going to do is you're going to take the natural log of each side. Okay, so you're going to have the natural log of 5, 2x plus 3 is equal to the natural log of 3, x minus 1. Okay, you're going to watch. This is going to get messy really quickly, so you have to be very meticulous. All right, so we can bring down the exponents now. 2x plus 3 times the natural log of 5 is equal to x minus 1 times the natural log of 3. All right. Remember, natural log of 5 and natural log of 3, they're just constants. Okay? So I'm going to distribute it. So this would be 2 times natural log of 5x. So 2 natural log of 5 times x plus 3 natural log of 5. And then distribute, okay, distribute is equal to x times the natural log of 3 minus the natural log of 3. So here's what you want to do now, okay? You want to get everything with an x on one side of the equation and everything with a constant on another side. So look, I'm going to add this natural log of 3 over with this constant. Okay, so watch. 3 natural log of 5. I added this over, so plus the natural log of 3 is equal to x natural log of 3. And then I'm going to subtract, subtract this over, so minus 2 natural log of 5 x. So how do you solve here now? Okay. Look, these both have an x in it, so let me factor that out. All right, and then I'm going to flip the equation around. So it's x natural log of 3 minus 2 natural log of 5, because I factored out the x, is equal to this right here. 3 natural log of 5 plus 3, or excuse me, natural log of 3. This is just a constant. This is just a constant. So what are you going to do? You're going to divide both sides of the equation by it. Look, these cancel. And this is what you're left with. X is equal to this. 3 natural log of 5 plus natural log of 3. I know this is crazy. Divided by the natural log of 3 minus 2 natural log of 5. Look, and then you can figure out what this is roughly in your calculator, okay? Now again, you just have to be meticulous plugging this into your calculator here. So you have to put the numerator in parentheses. So this is 3 times the natural log of 5, close that natural log parentheses, plus natural log of 3, now divided by, start a new set of parentheses, natural log of 3 minus 2 times natural log of 5. And going out to 3 decimal places, x is negative 2.795. So it got messy. It absolutely got messy, and that's okay. That's okay for it to get messy. Just remember that these things like natural log of 5, they're just constants. They're just a number. Okay, so treat it as one. Okay. You'll get a chance to practice these. So, you know, just again, as you can see what I'm doing here, be meticulous. Be meticulous as you solve these. All right, now let's talk about another method for solving. Okay, so this is about using the definition of a logarithm to solve logarithmic equations. Okay, so this is going to be equations that you express the equation in this form. You're going to have log base b of m is equal to c. Basically, you're going to use the definition of a log to rewrite the equation in exponential form. Okay, so that means this equation here becomes b raised to the c power is equal to m. From there, what you're going to have to do is you're going to have to solve for the variable, and then this is important. You have to check the proposed solution in the original equation, okay? And you have to make sure that whatever values you solve for, okay, do not violate the domain of a log. So it has to be that m is greater than 0, okay? All right. Log base b of m is equal to c will just be rewritten as b to the c power is equal to m. Okay. Let's do a bunch of problems. So let's solve this first one here. We'll start with an easy one. Log base 2 of x minus 4, okay, is equal to 3. All right, so when you have just a log on one side, you're just going to rewrite as b, look, going back, b to the c power, so the base of the log raised to the c power, so this would be 2 to the 3rd power, is equal to whatever inside the log, which is x minus 4. And then look, so I'm going to just move this around a little bit, so this will be x minus 4 is equal to 8, and look how easy this is to solve. You're going to add 4 to each side. And I'm saying here x is equal to 12. And look, that is an okay solution when you check it. You know, you have log base 2 of 12 minus 4 is equal to 3. And yes, absolutely, log base 2 of 8 is equal to 3. So yes, long as whatever you plug in here doesn't result in a negative, you're good. You're good. All right, let's try this one. Let's look at 6 times the natural log of 2x is equal to 30. All right, so the first thing you're going to do, you want to get the natural log by itself. So the first thing you're going to do is you're going to divide both sides by 6. All right, and then you're left with the natural log of 2x. Well, 30 divided by 6 gets you 5. So be careful here. What is the base of the natural log? Okay, base of the natural log is e. So you would have e to the 5th power is equal to 2x. Divide this by 2, and you're just left with x is equal e to the 5th power divided by 2. And look, if this is a positive number, so if you plug this in here, all right, it'll be a positive number, so it checks out. All right. Let's do some other ones. We can just kind of see a little bit more. Let's try... Yeah, let's do this one. Let's look at the natural log of the square root of x plus 4 is equal to 1. All right, here's how I would tackle this problem, okay? First thing, the square root makes this hard. So I'm going to write this as the natural log of x plus 4 to the 1/2 power. All right, well, what can you do with the 1/2? You can bring it out front. So you have 1/2 natural log of x plus 4 is equal to 1. Now, how do you move the 1/2 to the other side? You're going to multiply both sides by 2. So you're left then with the natural log of x plus 4 is equal to 2. Now again, base e. So this is just x plus 4 is equal to e squared. Just rewriting it. Moving the 4 over, your answer then is x is equal to e squared minus 4. Which, like, look, if you plug this in for x, this is what's awesome. This becomes e squared minus 4 plus 4, so the 4's cancel. Square root of e squared is just e, and the natural log of e is 1. So, woo, checks right out. Perfect. Perfect. Let's try this one. Let's look at log base 4 of 3x plus 2 is equal to 3. You know, actually what I encourage you to do here is like just pause the video, right? Give this a shot, you know, see how you would solve this one, all right? You know, just kind of make sure you have an understanding. All right, so when you rewrite this, right? So this becomes 3x plus 2 is equal to 4 to the 3rd power. You know, even suppose you just got to check, right? You know, 4 to the 3rd power gets me 64. So this is 3x plus 2 is equal to 64. And then look, just a simple problem to solve. Subtract 2 to each side. You get 3x is equal to 62. Or x is equal to 62 divided by 3. Which, again, if you plug this back in, very much checks out. Very, very much checks out. All right, let me take these problems and let me now make them. Let me add just another, maybe one more layer of complexity to it. Okay. Let's look at log base 6 of x plus 5 plus log base 6 of x is equal to 2. So this is like, shucks, you know, now we got 2 logs here, right? You know, how do we handle this? So what you're going to have to do is you're going to have to combine this into a single log. So you're going to have to use your rules of logs, right? So I'm going to rewrite this as, this plus means this is log base 6 of x plus 5 times x, which is the same thing as x times x plus 5. Wow. Okay, now what do I do? Now I'm going to rewrite this as x times x plus 5 is equal to 6 squared. Well, now you just need to solve this, right? So this is x squared plus 5x when I distribute is equal to 36. So now you just have to solve this as a quadratic equation. Move the 36 over. You just have to solve this now by factoring, right? Like what two numbers multiply to negative 36 sum to 5? That would be x plus 9 right, times x minus 4. And so you have two solutions, right? So you have solutions, either x can be equal to -9, right, when I set that equal to 0, or x can be equal to 4. Well, so now here's the thing you have to remember, okay? You have to remember, like, if I plug -9 back into this, I would get a negative in the log. So you have to reject x is equal to -9, okay? So that means our only solution, because if you were to plug -9 in, you would get a negative in the log, right? Like, you can't have that. So the solution then is just this one solution, that x is equal to 4. And look, it actually checks out, right? If you were to plug that into this equation right here, right? So you would get 4 times 9 would be 36, and log base 6 of 36 is indeed 2, right? Because 6 squared is 36. So that totally works out. All right, let's try this one. All right, so you just saw me do one. So let's try this. Log base 2 of x plus 2 minus log base 2 of x minus 5 is equal to 3. All right. So now how would we solve this one, right? So, here we combine into a single log using the product rule. Here we're going to combine into a single log using the quotient rule. That's why we learned all these logs in the previous rules of logs, properties of logs in the previous lecture. So this is log base 2 of x plus 2 divided by x minus 5 is equal to 3. So now look, this would be 2 cubed is equal to this on the inside here now, just rewriting it. So this is x plus 2 divided by x minus 5 is equal to 2 cubed. Now you just have to solve this, okay? So this is 8. All right, so you have x plus 2 over x minus 5 is equal to 8. Just solve by cross multiplying, right? So you have x plus 2 is equal to 8 times x minus 5. How are we going to solve this? Right, distribute here. Right, so this is x plus 2 is equal to 8x minus 40. Be careful. Be careful how you solve this. Okay. I'm going to try to keep things positive. So I'm going to add 40 to one side and subtract x to the other side. So this is 42 is equal to 7x. All right. And then, how would you solve this, right? You would just divide both sides by 7. And what do you get? X is equal to 6 when you do that. And so you just have to check this, right? Like if I plug, 6 into here, okay, I get 8. That's fine. If I plug 6 into here, I get 1. So it checks out. It works out. And if you were to go through and simplify the logs, you would see that it would work out. So again, just follow the properties of logs, to solve this. Okay. All right. Let's now, I know it's been a long lecture with a lot of examples, but we got some more to work through. Okay. So this is our last method. Okay. And this is using the one-to-one property of logarithms to solve logarithmic equations. Okay, so I want to express the equation. This is what I want to get. I want to get it in the form of log base b of m is equal to log base b of m. Okay, so this involves a single logarithm whose coefficient is 1 on each side of the equation. So I want to get a single log on each side. Nothing in front. Nothing in front. That's important. Okay. And then what you're going to do is you're going to use the one-to-one property to rewrite the equation. So if you have log base b of m is equal to log base b of n, then the insides of the log must be equal. Okay, must be equal. So then what you're going to do then is you're going to solve for the variable, and then this is super important. Then you just need to check. You need to check your solutions to make sure that you have m is greater than 0 and n is greater than 0. So you're not plugging any negative logs into the, any negative values into the logs. All right. Let's just work a bunch of examples so you can see. All right. So let's solve this one first. 2 log of x is equal to log of 25. Well, look, there's a 2 in front. So remember, you have to just get logs by itself. So I have to use my power rule to bring this up as an exponent. So this is log of x squared is equal to log of 25. Well, what that means is the bases of the logs are the same. So it must be then that x squared is equal to 25. The insides of the log must be the same. So when I take the square root here to solve, I get x is equal to plus or minus 5, right? But remember, you can't plug a negative into the log. Okay, like watch. If you take your calculator and you're like, oh, let me see what log of negative 5 is. You'll get an error, right? You can't do that. So you have to reject the negative 5. And your only solution is x is equal to 5. So we got it. All right, let's try this one. Let's look at log of x plus 4 minus log of 2 is equal to log of, let's have 5x plus 1. So you have a bunch of logs here. So remember, you have to get a single log on each side. So I'm going to have to combine this side, the left-hand side, using the quotient rule. So this is log of x plus 4 divided by 2 is equal to log of 5x plus 1. So now look, the base is the same. So you just have to solve x plus 4 divided by 2 is equal to 5x plus 1. So look, just multiply both sides by 2. 10x plus 2. You're going to subtract an x over. So you get 4 is equal to 9x plus 2. Subtract 2 from each side. And you're just left with 2 is equal to 9x, or x is equal to 2/9, which you can plug in, and you do not get a negative in the log. So that's the solution right there. All right, let's just work through a couple more. All right, now I want to do some ones that are a little bit harder, a little bit harder. All right, so let's try this one now. Let's look at log of x plus log of x plus 3 is equal to log of 10. All right, got to get a single log, okay? So I'm going to rewrite this as log of x times x plus 3 is equal to log of 10. Well, look, bases are the same. So you literally have x times x plus 3 is equal to 10. You just got to solve this, right? Distribute, so you get x squared plus 3x is equal to 10. Subtract the 10 over. What two numbers? Now you just got to solve by factoring, right? What two numbers multiply to negative 10, sum to 3? Well, that's 5 and negative 2. So look, your possible solutions, all right, you have x is equal to minus 5 or x is equal to 2. But look, so which one are you going to reject? Think about this, right? Which one are you going to reject? Well, you can't plug the negative in here because you get log of negative 5, or over here you get log of, end up being negative 2. So you're going to reject this. So the only solution is x is equal to 2. All right. This is a fun one. Let's try this one next. You're going to see something interesting when we solve this, okay? Let's try this. Let's look at the natural log of x minus 4 plus the natural log of x plus 1 is equal to the natural log of x minus 8. All right, again, combined to a single log. So this is the natural log of x minus 4 times x plus 1 is equal to the natural log of x minus 8. Well, look, bases are the same. Boom, boom. So you have x minus 4 times x plus 1 is equal to x minus 8. All right, when you FOIL this out, you end up getting x squared minus 4x plus 1x minus 4. So you end up getting x squared minus 3x minus 4 is equal to x minus 8. So when you subtract an x and add 8 to each side, you end up getting x squared minus 4x plus 4 is equal to 0. Well, what two numbers multiply to positive 4 sum to negative 4? You end up just getting x minus 2 times x minus 2. So you only have one possible solution then. It's got to be x is equal to 2. But here's the thing. This is why you always have to check your answers. Always have to check your answers. If you plug 2 into here, right, you get 2 minus 4, that's negative 2. Or 2 minus 8, you get negative 6. So you have to reject it. When that happens, when you reject all of the possible solutions, that means there's to this equation here, there's no solutions. So you can write that as the null set here, like that. Okay, we've made it. Let's do one last problem here. Okay. Let's look at the natural log of x minus 2 minus the natural log of x plus 3 is equal to the natural log of x minus 1 minus the natural log of x plus 7. All right, got to combine them to a single log. So this is the natural log of x minus 2 divided by x plus 3 is equal to the natural log of x minus 1 over x plus 7. Now look, bases are the same. So you just have to solve this. X minus 2 over x plus 3 is equal to x minus 1 over x plus 7. Well, how do you solve this, right? You cross multiply. So you have x minus 2 times x plus 7 is equal to x plus 3 times x minus 1. Okay, FOIL this out. X squared minus 2x plus 7x minus 14. So you get x squared plus 5x minus 14 is equal to, over here, x squared, 3x, 1x minus 3. You get x squared plus 2x minus 3 This is awesome. Look, you subtract x squared from each side. So those are gone. So now you just have to solve this. 5x minus 14 is equal to 2x minus 3. So you have 3x minus 14 is equal to minus 3. Add 14 to each side. And then just divide by 3. And your solution is 11/3 here. And you can plug that in, and at no point would you get a negative within the log, and you got it. All right, class, I know this was a long lecture and there were a ton of examples. But, you'll get a chance to practice, and, keep working at it. This will get easier and easier as you do. And then if you have any questions, please just let me know.